So we're not having a quiz tomorrow, but the quiz or test that we have next week is going to start out like this, analyzing a polynomial graph, right? So question 1, it says, is this an odd degree function or an even degree function? What do you guys say? Even. So why is it even? Because you determine whether it's odd or even based on the end behavior. Right here to the left, it's going down. To the right, it's also going down, which means that both of them are down here. So how many arrows are pointing down? 2 of them. And that's an even number. Now, if you had one down here and one up here, that would be an odd degree function, right? So because they're both pointing down, 2 of them are pointing down, that means it's an even degree function. Now, what does that actually mean, that it has to be an even degree function? It might be y equals x squared. It might be y equals x to the 4th. It might be y equals x to the 6th. It might be y equals x to the 8th, right? Okay, and we'll deal with that later. The next question it says is, the leading coefficient of this polynomial must be positive or negative? What do you guys say? Negative, right? This is opening down, which means that it's negative. If it were opening up, it'll be positive, right? It's also important to note, because it's even, they're both going down. The a value is negative, the leading coefficient is negative, but it's also important to think about an odd degree function. Let me just do a quick sketch right here on the side of an odd degree function, because I might ask this on the quiz. If I had there's my odd degree function, okay? Is that a value positive or negative? How do we know? If I were to graph the easiest type of line, y equals x, right? That would be this right here. So that's how you know if your leading coefficient's positive or negative, okay? If your leading coefficient's positive, it's going to go through this first quadrant and this third quadrant, yeah? So same thing here. If it's on your first quadrant and third quadrant, then this leading coefficient will be positive. If it were something like this, then you know if the leading coefficient's negative. Do we got that? I hope so. Anyway, those are when you have odd degree functions. But over here, obviously, we're dealing with an even degree function. So both of them are going down, which means that the leading coefficient is negative. So the answer number 2, leading coefficient's negative. Now let's fill in the blank when we describe the correct notation of the end behavior. So we all need to know this. X arrow negative infinity, what does that mean? As your x values approach negative infinity. So here are your x values. Here's 1, here's 2 for x, here's 3 for x, 4 for x. So going this way is positive infinity. Over here is negative 1, negative 2, negative 3. Oh, this way is negative infinity. So when I say as x approaches negative infinity, I'm really saying as it goes to the left. Okay? As it goes to the left, what happens to your f of x function? As it goes this way, what's happening to this?
Going down.
It's going down forever. So what do we say? F of x approaches what? Negative infinity. Does that make sense?
Yes.
Okay, good. And now when we read this next part, it says, as x approaches positive infinity, that means as you look to the right, here are your x's. Where's positive infinity? 1, 2, 3, 4, 5, 6, 7, 8, 9. Positive infinity is that way. So what this says is really saying, as you look to the right, what's happening to your f of x function? It's going down forever. So what do we put here also? Negative infinity. So we need to get comfortable with this notation of end behavior. Moving on. How many real zeros are there on this polynomial function? What the heck are real zeros? Answers, x-intercepts, roots, solutions, whatever you want to call them. So how many does it have? 2. 1 right here, 1 right there. 2 of them. Then it says, which of the following could be real zeros of the graph? Circle all that apply. So could it be 0.5? No, because that's right here. There's no answer right here. So what's the answer? Negative 0.5. Is there any other one? No. I actually wanted to put a negative 3.5. I accidentally put 4. My bad. But who cares? We'll just says all that applies. So this is the only one that applies. Because there's 1, 2, 3, 4. So that'd be 3.5, not negative 4.5. So this is definitely not an answer. if negative 3.5 would have been there, that would have been circled as well. All right, so number 6, state the max value, not the relative max value. So you need to know your vocab. What's the difference between your max value compared to your relative max value? What's the difference?
The relative is not the highest point.
The max value is your highest point.
The relative is not.
The relative, remember yesterday we copied down the definition of relative max and relative minimum. Relative is just the max value in a little piece of your graph. Relative minimum, it's the minimum value in a little piece of your graph, right? So which one is the actual max value? In other words, what's the highest point of this graph?
-2.
Right here. Yeah, -2, +4. So everybody should write that down as the location of your absolute max value. -2, +4. That's your max value. This guy right here, max. This guy over here, that's a max value also, but it's not the real max. It's called the relative max. So if I just look at this little piece of it, yeah, that looks like a parabola. That's the max value, but that's only the max value of that little piece. So that's your relative. That's what we call the relative max. So maybe on your paper, you guys should jot down those notes, max, and then right here, relative max. And notice that right here they ask you this question: which of the following could be the x value of the relative max value? Circle one. Not the actual coordinate, but just the x value of the coordinate. So what would the x value be right here? 2.5. Perfect. So 2.5 is the answer to that one. And number 8, state the relative minimum. What's the lowest point? What is the minimum? What's the lowest point of this whole thing?
Infinity.
And negative infinity, right? Because this goes down forever, goes down forever. So there is no real minimum. It goes down forever. But there is a relative minimum right here. And what's the location of that relative minimum?
-5.
Thank you. Relative minimum, 1, -5. Okay, now this next one, this polynomial function must be at least a degree of what? 4. How do we know? The directions that you're traveling in, right? So it's going up, that's 1 degree. Going down, 2 degrees. Going up, 3 degrees. Going down, 4 degrees. Simple as that. So this has to be at least a 4th degree function. The domain are your x values. Does this graph go to the left forever? Yeah, even though it goes down, it keeps going to the left forever. Does this graph go to the right forever? Yes, even though it goes down, it keeps going to the right forever. So what's our domain? Just like any parabola, it's x equals all real numbers. Now the range, sometimes it is all real numbers if it's going up and down forever, but this one's not going up and down forever. This whole thing is right here at this y level and below. Everything is below that y value of what? What's that y value, guys? 4. So the range is all at 4 or below 4. The graph is all at 4 or below 4. So what am I going to say? Y is less than or equal to 4. And that's it. There's a lot of vocab, a lot of things to know about this. So I recommend you guys study this, especially for the next quiz next week or test. I don't know, I haven't decided.